Welcome in to another new podcast from the Association for Materials Protection and Performance. My name is Ben Dubose, and I'm a staff writer with Materials Performance Magazine, also known as MP. Today, in the latest episode of our MP interview series, we're continuing our mini-series to spotlight some of the newer technologies designed to assist against the war against corrosion. In late April, as many of you are likely aware, we announced winners of the 2021 class of the MP Corrosion Innovation of the Year Awards program. These winners, which you can read about at materialsperformance.com, were graded and judged by a panel of industry experts across numerous fields and sectors within corrosion control. Anyway, over the coming weeks and months, we're inviting each of these winning groups onto the podcast to talk just a bit more about their innovation and how they think it can potentially change the corrosion industry in the years ahead. Joining us today, we have Dr. Patrick Dodds, CEO and founder of Hexigone Inhibitors. Welcome to the podcast. How are you?
Hi, Ben. Thanks for inviting me and looking forward to this opportunity. We're really grateful for the award we received from AMPP and talking about our discovery.
Yeah, absolutely. We're glad to talk a little bit more about it. And of course, you've been a loyal supporter of MP for years, also, well, now AMP. And so I think this will be a good opportunity to sort of explain your perspective for our audience, our longtime and, well, some of our newer members as well, given the merger. Anyway, I think a good place to start, if you could, just introduce yourself and tell our audience a little bit about your career in the industry, your role with Hexigone, and I suppose if you could, a little bit about the history of Hexigone as well, because it's a pretty unique story how you guys were formed.
Yeah, absolutely. So for me, it really wasn't, when I started out thinking, I'm going to get a career in corrosion or corrosion technology. I was actually working as a pharmaceutical scientist making clinical trial material. So I did a lot of milling of dry powders and decided to go back to university. I got paid to do a doctorate, which was great. So I got a salary to go and do my doctorate, and it was sponsored by industry. So all the research at the Swansea University is linked to industry. So it's all very relevant. There's no it's all solving the problem for industry. And my problem that I had to solve was finding a replacement for hexavalent chromate in the coil coating industry. So that started in 2011. I did loads of work, 4 years, ended my doctorate, and then suddenly we found something that worked so well that my student who was working with me, I didn't believe they'd set the test off. And then after a month, I did it. And then my professor didn't believe me for a month. And then it just kind of all skyrocketed from there because they'd never seen anything performing. So we looked at smart release reservoirs rather than a chemical or a different iteration or a lot of the ones you see are phosphates or different polyphosphate iteration on the market. What we did is we look at smart release vehicles, so a reservoir system that locks onto inhibitor systems and then only releases them on demand. So it's a totally unique concept. And although there's quite a lot of academic work on it, what we did is instead of writing a paper on it, we put a patent on it, and that's how we have ended up where we are today.
So tell us a little bit more about your winning innovation. What is it, and generally speaking, how does it work?
Yeah, so as I say, to expand on that smart reservoir system, we use what we term chemical intelligence to look at characteristics or properties and engineer the material. So in this instance, we engineered the system to be affinitive with the inhibitor, lock it in, and then it needs a corrosion trigger to release. So this then means that it sits in the coating, and only upon an event of corrosion would it release its inhibitor, which is highly effective. The other part of it is that our product not only increases the life cycle of your assets, so it helps in that way for sustainability. In some instances, we remove hexavalent chromate, very toxic, from the supply chain. So that's a big driver. In Europe, it's actually illegal, apart from some exclusions. But also then you've got your chrome freeze, so something like a zinc phosphate. And what we've enabled our customers to do is obtain better performance than they were getting with 29% of an active. And by using our smart release reservoir system, we've actually reduced the amount of chemical needed to do the protection down to around 2%. Another bonus, and they just kept coming, and it's great for us, but we're working with an adjacent chemical industry, taking their waste stream, and we process that and then we turn it into our product. So we're dealing with their waste stream, and it means that we get a cheaper raw material to work with, so we can pass that on to our customers as well. So it makes us very attractive to the market, not only on the performance, but we can compete with some commodity products like zinc phosphate by utilizing a lot less. Your cost per litre of paint is a lot less. So you'll get patented technology for cheaper than you'll get, and higher performance than you're getting for your commodity product.
So how long has this been in the works? If you could just take us back to sort of the origins of it and the driving forces. I know you touched on this a little bit already, but basically how this came to be and what the motivations were to sort of develop this. And I suppose also the point in which you realized that you guys really had something here.
Yeah, so I'd say take us back to 2015, the end of my doctorate, and we realized at that point that there was something very incredible about this system and how it performed, and how it outperformed hexavalent chromate by a long way in the lab tests. But also then we took it into an industrial setting, and once we got the results back from that, we really knew we had something. What really kicked it off, I don't know if you set off on this journey thinking I'm going to have an corrosion inhibitor journey at the end of the journey. I don't know what, at the time we didn't know where. We're very much more focused now, but when you're in the university setting, it's kind of what if this or that, or who's going to take this on. And I think it was we won an award from they're called the Armours and Braziers livery, and they're in London. They're a very old society. So these guys actually go back to when you had armour, and this is the livery company of all those companies that were making armour. They carry on now, but they're more material science focused. So we won their material science venture prize, which kicked off forming the company, and that was kind of the first step of turning it into a not university discovery, but a commercial company. And kind of thinking, well, maybe we do have a chemical or corrosion inhibiting company. And a lot of people have told me not to do it along the way. And I think I'm so pig-headed that we just carried on and doing it, and we're doing it. And actually now we're producing at the tonnage level and further beyond after this year. So it's one of those things that you don't expect to set out to do this, and you've got 1,000,001 people telling you not to do it. And I think people, sometimes got to do that, make that step, take that risk, and realize that not just having that academic research, you can make a commercial product. And currently I'm employing around about 14 people in around about 2 years. So I couldn't work on the product because I had a conflict because I was working for a very large steel company at the time, who were potential customers. So I couldn't work on it fully. So I won an award from the Royal Academy of Engineering. We're not award chasers, but we do chase the money. And this is a great one from the Royal Academy of Engineering. They do it every year, quite a few times now. You get a certain chunk of money, so that'll pay for my salary for a year.
Yeah.
You get training for a year to teach you from being an engineer into a CEO. It was really helpful. And then you get given around about £25,000 to get the company going as well. So and none of it's equity based. So it's you take the awards. The awards come with money. We were just scrabbling around. How can we fund this? How can you get this? Money doesn't just come from nowhere. It's very hard to get grants, and it's not so straightforward. We have had a few grants now, but at the time, so we managed to get these. And again, not to name drop, but the Royal Society, we managed to get an award through them that funded our first jet mill. So that enabled us to micronize our product very quickly, and then have a commercially viable, ready product all ready to go out onto the market.
So when you deal with some of these clients that I'm sure have looked in the past at various inhibitor solutions, what are some of the questions that you're having to answer? What's some of their, I don't know if skepticism is the right word, because that sounds a little bit harsh, but I suppose they look at some of their challenges and they know what you're trying to address, but at the same time, there's these historical limitations. What are some of those questions that you often get when you have a client that wants to know, how your solution is going to succeed when others historically have not?
I think we've got a totally unique system. There is honestly nothing like it on the market. I think that helps. I think having 30 years worth of research behind us, all our validations are done independently. We've got some customers who are kind enough to let us share their data from their full code posting systems. So we've got all this backup that first of all, we're scientifically based from the university. They've designed machines that can see through coatings, so we could test in 24 hours. You know, I made, I don't know, hundreds or thousands of different iterations of which we would test, and the different systems and clays and all these different things in there. So it's not just we tried one test and it happened. We've got a lot of scientific base. They're solid in electrochemistry. It's an amazing department, and the professors there are incredible, and really unique equipment they've made in-house that other universities buy off them. So we've got a bit of credibility before we get going, but the test results really speak for themselves. You can't deny what you see in the images on the corrosion data, especially on steel. You know, it's loads of red rust or very little red rust with our product, and this has helped the market. You know, they will have to do their own validations. I do have to say, there's sometimes you get this reluctance and you get this not invented here syndrome, and we've experienced this with the larger companies, because generally they've got some of their own technology they've developed, or they've got an expertise center that, you know, where have we come from with this, you know, and so you do find a lot of reluctance from these guys there. And you know, you might get this rhetoric, oh, it's not any better than what we're currently using. It's like, well, we know it is, but you know, there's a reluctance to change. That, I think that's one of the biggest things. It's a really conservative industry. You can't deny it.
Right.
You know, in Europe, we would still be using hexavalent chromate, but it was banned by law. You know, so they've had to change, and that's just because of legislation. Otherwise, I can't see it would have changed. Really, but what we are seeing is now it's kind of a bit of a domino effect. So we're working in Japan, the US, India, and they've all got impending bans in India and Japan. They have got this ban coming into force, and I wouldn't be surprised if the USA doesn't kind of follow suit as well at some point. But we do have a lot of, especially the military, are really trying to move away from hexavalent chromate as well. So you've got this. We can remove. I think there's not been that product that's matched the performance of hexavalent chromate. For all its toxicity, it is very highly performing, but it's so dangerous and it's caused so much cancer that, you know, they want to move away from it. So if we can give people an option of removing that highly toxic compound from their supply chain, we will help them do it. And subsequently, weirdly, one part of the inhibitor system that we're using is actually taken as a pharmaceutical. So, you know, we're never saying to people, you know, swallow our product, but you know, it's a hell of a lot safer than something like hexavalent chromate, and we can give you the performance that you would get from hexavalent chromate. In fact, we just in some independent tests matched the performance of hexavalent chromate from 2 tier 1 companies, and it was their chromated or chromium 6 products that are on the market today, and someone had independently tested ours against theirs and demonstrated that we had equal or increased performance. So there's no real reason why, if you've got performance, you're still using that toxic compound. You know, that's a question that needs to be asked, is if you can get a move away from that, you've got the performance, we've demonstrated the performance, so why are we continuing to use something that's really dangerous? And then on the other side, you've got the chrome frees, as we call them, and they don't match the performance hexavalent chromate. So you kind of get into this middle ground of it gives you okay performance, and we're saying, well, we can give you better performance. Just for one example, so we were working with a customer recently. They would, in their system, they're using 14% of zinc phosphate. I can't say who it is, and I'm not going to divulge any more information. We don't know that either. We do know it, but we don't. We did it from, you know, kind of back calculating. So that's a much cheaper product than ours per kilo. But you can use 2% of zinc phosphate, and you put 3% of our product in. So you have a synergistic effect as well with phosphate-based systems. So we're not going in there and saying only use this one product. This is a silver bullet. It's kind of use it in combination, look at the characteristics from one and the other one, how they work together, and then you start getting this performance that you're requiring or exceeding your current performance. So we work in synergy with that. And what we've demonstrated is we've reduced the amount of active chemical in that coating system down to 3.2%. But given it excellent performance, 2,000 hours plus of cyclic testing, and will be going out and used on infrastructure by that customer now. And we gave them over 25% saving in their costs associated with the corrosion inhibitor additive that they're putting into that primer system. So it's kind of like, oh, and the other one, next one we had, but this isn't intentional. You know, it's kind of like things are all aligning. we actually reduced the VOC content of that primer system by about a quarter.
Wow.
So we're kind of, you sit there and you go, well, surely you should just be buying this now. But you do have a bit of a conservative industry, so it's just getting through those barriers and having an understanding investors who understand that there's a very nice market at the end. We've just got to get through the conservativeness, demonstrate all these benefits of moving over, and then we get to see the sales increase.
You mentioned the data, which sounds fairly enormous. What type of field testing are we talking about with this? How are you collecting the data, and just shed a little bit more light about exactly what it is that you're able to show statistically?
So most of the data we have that we're allowed to share is from customers who've trialed it against their current systems. We've only had as a drop-in replacement or a substitute. They would make up it with filler, but we've got another advantage that our product has a much lower specific gravity than the other systems. So by weight, you get a much bigger volume, and actually because of the reservoir system, you get a solid content added in there because of our product also. So it kind of just is that we are demonstrating these effects. We got the accelerated test is mainly the ones we're allowed to share. So you kind of salt spray, click testing, humidity. There's a lot of companies who won't let us share any data because of how we perform with their current system. We wouldn't ever do that anyway. You know, we respect our NDAs, and we expect our NDAs to be respected also. So yeah, it's one of those things that we've got data in field, outside data as well. Again, that's not so much that we can share that data, but because we've got confidence built from the very electrochemical reaction basis and the performance there through to the field testing, we know the product works. We wouldn't be doing this if I wouldn't have started the company from an engineering point of view if I hadn't had that solid scientific basis to work off and then move forward. You can't make up performance; it has to perform. There's no two ways about it.
What type of feedback have you gotten from users that have actually adopted it? We've spent a lot of this podcast talking about sort of the conservative nature of the industry and needing folks to give it a chance. From those that have given it a chance, I know you can't go into specific results, but just talk a little bit, if you could, about, I suppose, the types of applications and what it is that they're seeing.
Yeah, so we've had good results from aerospace and protective coatings. That's our main push. Because the market's a bit more responsive than the other markets. We've got good results in core coating. We've got some mixed results from core coating as well, but where the test hasn't been done correctly. So I'm always trying to ensure that they're doing things correctly. I've got a big background in core coating as well because of where the doctorate started. So I understand all the interlayers in there. So what we've had is good results from across all those industries. And it's a significant difference in performance. It's not small, it's significant, especially when you're looking at mild steel protective coatings or galvanized steel, but mild steel especially because the speed at which it deteriorates, and then you can see the difference between our products and other products much quicker. So that enables people to make that decision a lot quicker. And then there's a few driver forces in there. So it depends who your customer is. We've got all these benefits, but for one customer, purely it was based upon saving costs on their raw materials, but also getting a better performance at the same time. Other ones is we can remove the dead fish and dead tree symbol from the paint tins by utilizing our product. So that's a big boon for them and then their customers as well. The performance is really what a driver in the aerospace industry. We've compared against things that are 16 times the cost of our products, and we're being touted as the next best thing to chromate, and actually we hugely outperformed them, and you didn't need to grind ours down to a nanoscale. So the performance is probably where we start, but then once you get into the more commercial conversations, it's cost is always significant driver. for anyone, I think. And if we can reduce those costs, I guess, especially against something like a zinc phosphate, then, it's insane that we're £10 a kilo, say, or £15 a kilo, or £20 a kilo, depending on your grades. And then you're competing against something that's £3.57 a kilo, but we can still beat them on cost because you have to use so much less of our material to gain better performance. And that's the main driver for us, is sustainability and increasing the life cycle of assets, making better paint. Lots of paints made every year, lots of paints removed and repainted, and that's got a significant amount of drain on the Earth's resources. And we've just done a piece of work, and we actually found it from a piece of Norwegian research that looked into the amount of new steel that's needed to replace corroded material. And it's something like 40% of all new steel made is done to replace corroded metal or corroded steel. So that accounts to 3.2% of the world's CO2 emissions. And if you take, for instance, the aerospace industry, where there's a massive focus on their CO2 output, then they're only at 2.5%. So there's a whole big thing that we're missing here that we need to address pretty quickly, and that's our driver, is to make better performance coatings, less maintenance, less drain on the resources of the world, and utilizing a lot less to do it as well.
So what are the next steps as far as the path to commercialization? I know this has already started, so perhaps it's less about commercialization and more about just more widespread adoption, but basically what comes next when it comes to expanding the use and application of this?
So what we've learned is that the quicker adopters are generally your tier two, potentially still family-owned businesses, not necessarily, but potentially. And you can talk to a decision maker in there quite quickly. Whereas if you're approaching larger companies, it's a much longer sale. The volumes in the end will obviously be much bigger. But when you've got to get through multiple layers and departments and committees, so our focus is really working with our tier two customers across the globe as well. This isn't just the UK. We're working, there's a lot of work going on in Taiwan at the moment. We've got a brilliant distributor working there on our behalf. In Japan as well, we've got a great distributor who's working on our behalf. They've all done their own testing before they've gone to the market. And again, in Canada as well, and Europe, we're just making up getting together with that. So we're utilizing different streams and channels. We've done a lot of direct marketing ourselves. We've got an amazing marketing manager called Ella, who is very good at getting our technical articles into the right places so the right audience sees them. It's kind of a niche product, we're not trying to look for the bigger market, but I think tier twos is where we're really focusing on for us as a company, because they're hungry for market share. And by having a differentiated, better primer system, they can get their market share increased. And so that's really our company. We want to help them build their company. And then, a big focus then for us is protective coatings because of the speed at which it can go. So we've got several streams of who we're working with. There's the quicker ones to move forward. So they're at the forefront. And then we've got the slower burning ones moving along quite nicely in the background as well. And then we've got surprise ones that come out of nowhere. So we've just had an order come in this week from India. We weren't even expecting it. So it's kind of one of those. We're scaling the manufacturing, we're scaling the team at the moment. We've just taken on a commercial director. He's got 25 years of experience working through places like AkzoNobel and then Huntsman Pigments. So he's bringing a wealth of knowledge to that side of everything. And then on the other side of it, we've got Innovate UK loan from the UK government, very low rate to help innovation in the UK. And that's to pay for all our capital equipment to upscale the manufacture to the next step. And then beyond that, then we've got manufacturing partners and looking at potential partners in regions where the demand is as well. So there's a lot happening.
Yeah, definitely sounds like it.
Yeah. But it's all good. It's all moving in the right direction. And we've just had a round of investment to help us on that journey as well, because the time you have to wait for the validation, there is a cash burn in that period. And then once sales start coming in, everything starts to balance up again. But the investors are great. We've got some real industry hitters in our investment and real amazing experience between them all as well. So really driving us forward on that one as well.
We're wrapping up here with Dr. Patrick Dodds, CEO and founder of Hexigone Inhibitors, one of the winners of our 2021 MP Corrosion Innovation of the Year Awards. As we wind this thing down, one of the things we do with each of our guests are these rapid fire questions that are designed to let our audience know a little bit more about each of our guests on a personal level. So I think a good place to start with you, Patrick, would be who's someone that you consider a hero or a mentor to you? This can be for you personally, or this can be for you out in the industry.
Well, I think for me, my board is amazing. They're all mentors to me on different aspects of the company. We've got people who, like Phil Buckles, run his own coatings company. He built it up and sold it to Axalta in 2017. So he knows the industry inside and out. I've got the other team members as well. I've got the chair of the board who helps us on the different aspects of other things, and then our day-to-day team as well. They're also our mentors as well. I do have a mentor supplied by the Royal Academy of Engineering. So Dr. Peter Williams, he's a CTD of INEOS. So I think it's a lot. There's so many people.
Sure.
There's a lot, and it's not just one person. It's a collective of people that
Understandable.
Doing this journey with.
So let's go to the other extreme. What's something in a work capacity that's a really big pet peeve to you?
Well, my biggest one is not being open and honest. This is one of our core values in the company.
Mm-hmm.
Open, honest. There's no gripes. It's all open. I think people who put on a face at work, and it's not really them, and then there's another side to them. I don't value that in any way, and I think you need to be authentic in yourself in the workplace. So for me, if I'm working with people and they've got an ulterior motive, that's a no-no. They need to go. We work as a team, and it's not about one person. So that for me would be probably the biggest pet peeve I would have.
You mentioned earlier your university background. What's something that you would say to someone that's fresh out of school, a newcomer to the industry? What advice would you give to someone that's sort of just starting out on this journey?
On an entrepreneurial journey, I would say, it's hard work, but it's worth it. And in the industry, it's massive. I don't think you quite realise. I didn't even know before I went back to do my doctorate. It wasn't even on my radar, materials engineering or corrosion and the coatings industry. But once we're in it now, the realization of the global industry and the global nature of the industry, and it's significant, and also quite exciting and interesting, and the opportunities are huge.
So as we conclude this, for anyone that's listening that wants more information about you, about Hexigone, the technology, where can they find it? Basically, this is your spot where you can plug any resources that you all have for our audience and where people can get that information.
Yeah, absolutely. So go to our website, www.hexigone.com, and that's HEXIGONE.com. That's got all our information on there. Contact Sean Reed, our sales and commercial director. And there's an info at hexigone.com as well to send emails to. Team's more than willing and helpful, and we always get back to people. No one's ever left without a response.
Sounds good. Folks, that's where we will wrap up today's episode. If you want more information beyond what Dr. Patrick Dodds just laid out for Hexigone, you can also check out the AMP website at ampp.org, and you can also visit materialsperformance.com for all sorts of news related to the corrosion control industry. Also, if you have not already subscribed to this podcast, or if you haven't left it a 5-star review, please do. We're available at Apple, Google, Spotify, and virtually every major podcast distributor. With that, we'll sign off. For Dr. Patrick Dodds, I'm Ben Dubose. Thanks as always for listening, and please come back soon for another episode from the MP Interview Series.